So, hello students and welcome back to our video classes, and today we are going to discuss about the third lecture of Is Matter Around Us Sphere. Okay, I think you have watched the first two lectures and you have understood all of it. If you haven't understood it, then what you have to do is you just have to write it on the forum. Okay, so whatever doubt you have, you just write it on the forum. And today we are going to start with the solutions. Okay, now before going to the solutions, today we are going to discuss about what are the solutions, what are the solutes and the solvents, how a particular thing gets solubilized in other things, and what is the limit of this solubility. Definitely, we are going to learn about the factors affecting solubility as well. So there would be a very interesting class, and definitely we have some cool videos as well. Okay, so you just keep on watching it, and as I told you earlier as well, in each of these videos, so class 9 is a very important class. I think you can understand that, and each of these videos are containing so many informations. Let me tell you, you are going to learn the same subject, this not the same, what I mean is you are going to learn the same topics in class 11th as well. And I think can understand so how important these things are. Okay, the solution part, the solubility, solvent, solution, all these things you're going to learn in class 11th as well. So right now I think you got the importance of this chapter. So now we are going to learn about it in that details only. Fine. And apart from that, definitely we are going to discuss about some of the FAQs at the end of this video. Fine. So you got it, everything that we read in the last that we learned in the last two videos. I think you got everything of it. This was very simple. That was nothing difficult in those two videos. And if you have given your 100% attention, definitely you would be able to understand each and every subtopics or topics, whatever was there. Fine. So before starting, so definitely good morning, good afternoon, and good evening whenever you're watching this video. So depending on that, we would start with the solute, the solvent, and the solution first. After that, we would move on to the types of solutions and solubility. So first thing, we would start with solute, solvent, and solution. So if someone asks you, what do you mean by the word solution? What do you understand by the word solution? So what is solution? So now you know that solution is nothing but a mixture of two. So how does this solution comes? So you have heard about mixture, isn't it? You have heard about mixture. Okay. Now, if I just try to tell you what is a mixture, so you can see there are two or three different types of particles. When they just mix together, they makes a mixture, isn't it? So this is the mix, this is the particle, this is the particle. They just go, they are all, I mean the molecules, right? When all the molecules are together, mixing together, we call it a mixture, isn't it? Now, so now this mixture can be of so many types, right? Just think about it. If I try to, mix it up in such a way, that they are getting mixed evenly, like it happens for salt and water. So in salt and water, they just get mixed evenly, isn't it? So if that is happening, then we call it a homogeneous mixture, isn't it? Homogeneous mixture. And solution is just a homogeneous mixture. So in solution is something like when you just mix two or more particle, or when you mix two or more type of molecules in such a way that they makes a homogeneous mixture where you cannot see any of the solutes. Okay, that is called a homogeneous mixture, and that is called a solution. Fine. So that is solution. Now solution is made up of two things. One is solute, another one is solvent, isn't it? Solute and solvent. These two are the main constituent of a solution. Now, what is a solute and what is a solvent? So solvent is that thing that is inside the solution in greater amount. So solvent is the thing that is there with greater amount. And solvent is the part that is there in less amount. We would definitely go back there, definitely, and try to understand this thing again. Okay, so if I just start with this part here, if we just look into this thing, okay. Now here you can see the solute is something, as I told you, which is there in lesser amount, right? So if you are mixing salt in water, so this you can see like this example over here, you can take this as an example. So solute and solvent. So you can see water over here. This is water. So I am trying to draw the entire thing again. So if you just take a beaker, okay, if you just take a beaker, and if there is some water inside it, okay, let's just consider there is some water inside the beaker. Fine. Okay, there's some water inside the solution. Now you are mixing some blue color thing. Can you tell me what is this? This is nothing but copper sulfate. Okay, this is a copper sulfate crystal. So in crystallized form, it remains like this. Would you be able to remember that? We call it copper sulfate. So this is copper sulfate crystal. Okay, that is why it is like, you can see the crystals over here, CuSO4.5H2. We also call it one more thing. Do you know the name of copper sulfate? What do we call it? We call it blue. Now I think got it. Blue vitriol, right? Vitriol means oil. We call it blue vitriol as well. Fine. So this is copper sulfate. Correct. So copper sulfate is a blue colored solution. So when I am mixing this copper sulfate over here, so this copper sulfate over here, what is the solute and what is the solvent? Very simple question. So this is the solvent, and copper sulfate is there with lesser amount, that is called solute. That is called solute. And when they mix together, they are giving you a homogeneous mixture. So they have to give you a homogeneous mixture. Homogeneous mixture. True solution. So otherwise you cannot call it a true solution. True solution, the mixture is homogeneous. So it should be transparent as well. You can say that the solution should be transparent. Okay, transparent. And you would not be able to see any of the constituent particles. That is the criteria of a homogeneous mixture. All the things are particularly, very perfectly mixed with each other. Okay. Or you can also say, there is another term that you use. That is, we say like that. There is no phase difference. There is no phase difference. What do we mean by that? Phase difference means there is only one phase throughout the solution. You cannot say that there are two phases. Phases means there are three types of phases, right? Solid, liquid, and gases. Oh, three states, what I mean to say is. Okay. So phases are like just solids. What I mean to say is solids, liquid, and gases. So there would be only one phase. Okay. There would be either a solid or a liquid or a gas. There would be only one phase for a homogeneous solution. Okay. And the solvent is that part which is there in more extent. Okay. The concentration is more, right? For solvent, the amount is more, right? So here the amount, the thing was water only. So in most of the cases, we take water as a solvent, isn't it? Because water is, there you can see this is also water, because water is called a universal solvent because it can mix so many things. Universal solvent. Did you knew it? It is called universal solvent because it can mix so many things. Okay, so it has a very wide range of varieties. So like it can solubilize so many things. For that, we call it water as a universal solvent. Fine. So that is the thing about solute and the solvent. I think you got it. So in solutions, there are two parts. One is the solute, another one is the solvent. Fine. Now, as we have got it. So solution is always a homogeneous mixture. Fine. Solution is always a homogeneous mixture. But if we try to understand what is solubility, then let's see what is solubility. So now solubility is this is the amount, of solute dissolved. Okay, this is the amount of solute dissolved in unit solvent. If I take, okay, yeah, one more thing. At particular pressure, wait for a moment. Yeah, pressure and temperature. So when the temperature and the pressure is constant, when the temperature and the pressure are constant, only then they have to be constant. When they're constant, at that time, the amount of solute that can be solubilized in a particular amount of solvent, in unit amount of solvent, that is called solubility. Okay, most of the time we take solubility for 100. Okay, so the amount of solute dissolved in 100 so grams of solvent. Okay, amount of solute dissolved in 100 grams or 100 liters, we take it like that only. Okay, so if I just try to take give you the idea about it, so we can say like that. So solubility, when we are trying to most of the time we are going to denote it in percentage. So if someone tells you, that the solubility of NaCl, this is the thing they're asking you. So like we have seen, it was written the solubility of NaCl is 25 at 298 Kelvin, 25% at 298 Kelvin temperature. What do you mean by that? It means whenever you see this type of question, I think you got it. What does it mean? It means that 25 grams of NaCl can be dissolved in 100 grams of solvent. Okay, whatever the solvent is. So it would be like water or something like that. So in 100 grams of solvent, there would be 25 grams of NaCl. That was the thing. Fine. So this is called the solubility. Okay. Now let's check out video that is describing about solubility. That thing we would learn later. Okay. So effect of temperature and effect of pressure, we would definitely learn later. Right now, with the videos, I'm going to, make you understand of everything. So this amount of solute in grams dissolved in 100 grams of solvent to prepare a saturated solution. Yeah, so that was the thing I missed. So that was saturated solution. I think you got that part. Okay, I am trying to make it saturated, definitely, because we are solubilities here. I am discussing solubility after teaching you about solution. So in true solutions, when it is making something saturated solution, what saturated means, the maximum amount to which it can get dissolved. Okay, that is the maximum amount. Now solubility is something like when 100 grams of solvent is taking how much amount of solute, that is called solubility. Fine, in a particular temperature and pressure, that is the most important part. So I think right now you can sense something. So soon enough we are going to learn about the effect of temperature and pressure, right? Soon, because temperature and pressures are going to make some difference. That is why they are just saying that solubility has a for constant temperature and pressure, because if they get changed, something would change, right? That is the thing. So in 30 degrees centigrade, if you just take a beaker, okay, and so if you just there are 100 grams of water, okay, that is 100 grams of water and 10 grams of sugar is mixed there, so it would get easily dissolved. Now again he is mixing another 10 grams of sugar, okay, so again it is getting dissolved. That is the situation now. So when he is dissolving, so he has a beaker, okay, so at first there was water only. He dissolved 10 grams of sugar and it got completely dissolved and gave him like saturated solution, okay, and he mentioned the temperature as well at 30 degrees centigrade, gave him a saturated solution. But when he mixed another 10 grams, what happened is some of the particles left undissolved, okay, so some of the particles were left undissolved. Now what is this? You can see like this is not a saturated solution. We don't call it a saturated solution. So far I haven't told you what is a saturated solution so far, so definitely right now you just listen to it, or definitely go back to that position where we would be learning about saturated and unsaturated solutions. So just wait for a moment. So right now what would happen, there would be some particles left there. So what I mean is that would not be a proper solution anymore, okay, because solutions should be homogeneous. And you can see there are two phase difference, because some of the sugars are there, okay, undissolved. So sugars are solid, and this thing is liquid. There are two phases in this solution, isn't it? Not a solution, in this mixture I should rather say, there are two phases, right? In this thing there are two phases. So this thing is not a solution anymore, because it is not a homogeneous thing anymore. So for that reason, we cannot say that this is a solution. Okay, now I would just go back to make you understand about the different types of solution, and after that we would continue from there about the solubility. Okay, because you have seen that there is something called saturated and unsaturated and supersaturated solutions. So we would just go through that. After that we will come back there again. Okay, now fine, understanding it? Okay, types of solutions are there? How many types of solutions are there? There are mainly three types of solutions, okay? One is saturated, another one is unsaturated. Let me just make some changes. The third one is supersaturated. Fine. There are three types of solution: saturated, unsaturated, and supersaturated. Now, these three are the types. So now we are going to learn about them one by one: saturated, unsaturated, and after that we would go back to the solubility part. So first is saturated solution. First is saturated solution. So you can see, let's take an example, fine, a real life example. So this is you. Again, I'm starting to draw something. You know how good I draw, right? So now you have a saturated solution. Okay, so now we are trying to read saturated solution. So this is you. Okay, this is you. If you're a girl, you should have some hair, right? If you're a boy, then the previous one was enough. Okay, where are the ears? I like caps. Fine. So I'm just trying to draw a cap. Yeah. So that is the thing. You can see it's perfect, isn't it? So now you are going to a party. You are going to a party. And in party, you have so many dishes there, right? You have so many dishes. So already feeling hungry? Chicken leg piece. If you're not, so this is the chicken. Okay. So if you're not a fan of, non-veg things, so what else can you eat there? So these are the paneers, I guess, the paneer items, dishes of paneers. Okay, whatever you like the most. And paneer, I just there is something like paneer tikkas. Okay, I like that thing. I don't know if you like because yeah, I don't know who is watching this, right? And yeah, so that thing is good. I'm a pure non-veg. Okay, are you getting me? I'm pure non-veg. So I like chicken, I like mutton, those things. So yeah, sometimes I take paneer and all, but yeah, that is the thing. Um, yeah, let's just come back here. Now there are so many dishes. What else do you like? Like biryani. Biryani is good, right? You can see like I am prone towards the non-veg dishes only. I should, to make the balance, to keep the balance, I should, um take the next dish to be a vegetarian one. So there can be something like pulao, a purple colored pulao. Okay, pulao or fried rice, right? Fried rice would be like, yeah, pulao would be better. Going to a party, isn't it? It will be pulao. And what else? So ice cream and all. Okay, I'm not, I'm tired of drawing. Okay, just continue with this. So yeah. The thing is, if you go to a party like that, so all these dishes may, all this so, so tasty, and we would try to grab all of it, and we try to, have all of it. But the thing is, we have a particular limit to which we can eat, isn't it? So if you just look into it, then what would happen is, let's just say you would eat all of it, all of this paneer and the entire chicken. Okay. And you'd be eating the entire pulao, but you would not be able to eat biryani anymore. Okay, you're getting my point. When you are going to a party, you would eat up to your maximum limit. You would eat up to your maximum limit, the limit till which you can go. You would eat to that limit only, that level only. You would not be having any spaces inside your stomach to eat anything else. That is what happens when you go to a party, when you go to a ceremony, marriage ceremony, something like that, isn't it? A homecoming or something like that. So what happens is you eat to your fullest. Now you cannot eat anymore. That is called saturation. That is called saturation. When you have reached to your maximum limit, that is called the saturation. That is called saturation. So if I just consider a solution like 100 grams of water can take up to 2 spoons of sugar. If you just give it exactly 2 spoons, then it is a saturated solution. Got my point? So to the maximum limit. Okay, that is called a saturated solution. So let's just watch a video to understand it better. So you can see they're just trying to dissolve sugar and water. Sugar and water. So it contains water, that glass, and that is sugar. It is a no-brainer. Oh, there is nothing important they're saying. I'm just going to tell you if there is something important in there. So they are going to take a spoon and they are going to put it there. Yeah. Now, if you stir it, what would happen? You know that. Look over here, after getting mixed, let's wait for a moment. Yeah. Now here, just look into it. In this solution, you are in this mixture, I should rather say. Whether it is a solution or not, we would come to that later on. So in this mixture, you can see that is transparent, isn't it? That is transparent. And I have told you earlier, when you get a transparent mixture, when you cannot see the particles, we call it homogeneous, isn't it? We call it homogeneous. Okay. And the thing is, there is a big mouse just beside me over here. Okay, forget about it. So it's called homogeneous. You cannot see the different phase. You cannot see the different particles there inside it, and there is no such change in phases. So there is only one phase over there, right? There is only one phase. That is called a homogeneous solution, isn't it? So this a homogeneous mixture, and we call it solution only. So is it a solution? Definitely it is a solution, because you cannot see the sugar particles anymore. Okay, so that is a transparent mixture as well, and we call it a solution. Fine. It's completely dissolved, right? Now if we just keep on adding more sugar, again it got completely dissolved, isn't it? Yeah, they are doing it again. This is you eating those dishes, okay, to your fullest. Now you can see over here, this is the thing. You cannot mix anymore. Cannot mix anymore after a certain limit. So now they're saying that if you take a fixed quantity of water, you can only mix a fixed quantity of sugar in it. Okay. So now they are going to try with some other dissolvable substance, and they are trying to trying to see that whether all the dissolvable substance has this fixed quantity or not. So let me tell you, do not waste your time by watching this. Let me tell you, yeah. So definitely all of those substances, every substances has their own solubility limit, isn't it? So wherever you take, that would be like for sugar. Let's understand, for sugar it was maybe 2 spoons or 3 spoons. But if there is something else, if there is something like salt or something like that, there may be, for salt or something like that, that thing may be 4 to 5 spoons in that much water only. So it depends on so many factors. So right now I'm telling you, what I'm telling you, if it is a dissolvable substance, if that is a dissolvable substance, that has that may have different solute. Okay, so that is the thing. Okay, that mouse is just keep on coming and going. Okay, it's distracting me so much. Okay, just forget about it. Okay, now, so the thing is, now we are coming to unsaturated solution. Okay, so what is unsaturated solution now? So if you are going to a party and you are eating up to your fullest, that is a saturated solution. Now, what is unsaturated solution? The thing that happens when you get very low marks in your exam. That is called unsaturated solution. So let's just understand, like after you got your result out and you got only 50 out of 100, then what would happen? What would happen to you? This is your mom. This is you. So your mom's and she would be so angry, right? This is the fire coming out from her. She would be so angry with you. And what would happen as a result? She would not give you anything to eat, right? For that day. So you would be unsaturated. So there would be some, you would be so much hungry. And the limit your limit is not reached, that is called unsaturated. When the limit is not reached, when the limit is not reached, we call it unsaturated solution. Okay, so I think you got the point. Okay, so when the glass of water that can take up to 2 spoons of sugar, if you just mix 1 spoon, if you just give it 1 spoon, then that would be unsaturated solution. If you give it 2 spoons, then that would be a saturated solution, isn't it? Fine, got my point. Now coming to supersaturated solution. So I think you got it already. What is the supersaturated solution? So this is the thing when you are going to the party and there are so many things that you like and you cannot leave it there, and you try to eat more than you can take. That is a supersaturated solution. So when a solution like hypo is an example. Okay, hypo is a type of substance. Okay, so Na2H2O7 and O3 and 10H2, 7H2. So that is called hypo. So hypo is having, the solution like it can take more than what it like. If that is a limit, like it is a limit of 2 spoons, and if there is 3 spoons of sugar in that, then that is called a supersaturated solution. Fine. These are the 3 types of solution. Okay. Now I think now if you just come back over here, okay, to understand what is solubility. The solubility, I think this is clear to you. So when for solubility, you need to understand that it should be a saturated solution. To make it saturated solution, the amount of solute needed, okay, in 100 grams of solvent, that is called solubility. Fine. Now the factors affecting solubility, I think you definitely understand it. What are the first factors? So what would happen if you just increase the temperature? Just give me a moment. So what would happen if you just increase the temperature? So definitely for solubility, you have already got, one is temperature and the other one is pressure, right? These two are the things that I told you to keep it constant. So definitely you got the point that they are the one who are going to make the difference, right? So you can see the first thing is temperature only. So how temperature affects solubility? They are saying that by changing the temperature, we can increase the solubility of a proper solute. Okay, so think about it. If you have like 2 spoons of sugar, if you can mix 2 spoons of sugar in like 100 ml water, in 100 ml water, if you just start heating it, what would happen? Definitely what would happen? So what is happening actually, the thing is, if these are the 2 water molecules, okay, so you know that in between 2 water molecules there is a space. So I'm just trying to take 2 water molecules, right? So if there are 2 water molecules, there is a molecular space, right? We call it intermolecular spaces, right? Isn't it? So there is an intermolecular spaces in between 2 water molecules. You can see over here. Okay, whatever, however it is arranged in that way. Okay, if it's arranged like this, then that is the intermolecular spaces. There should be intermolecular spaces because we know that with respect to that only we have differentiated solid, liquids, and gases with respect to the intermolecular spaces only. So definitely we can say that with respect to the intermolecular spaces, solids have the least spaces. After that comes liquid. After that comes gases. So the thing is, what is happening over here? The thing is, if this is a molecule, water, this is the water molecule. So that is the intermolecular space. Okay, intermolecular space. So when I am putting a solute over there, when I am putting a solute over there, So the solute is coming. This is the solute. So it is just trying to, fit itself in between these two water molecule only, in the intermolecular spaces in between two water molecules. Okay, so that is how you can see that whenever you mix sugar or salt in water, that get dissolved and disappeared. That solid substance is getting completely disappeared. So how is it happening? So actually the thing that is happening is the particles are getting in between two molecules. As a result, you cannot see it. That is there inside the intermolecular spaces in between two molecules. For that it is happening. So the thing is now when you start heating the object, what would happen? So these are spaces in between them. These are the molecules, there are some spaces in between them. When you start heating it, what would happen? The kinetic energy of, so the energies of each of the molecules are increasing. Energies of, because you are giving energy, isn't it? You are giving energy. If these are the molecules of water, all of them are the water molecules. Okay. Now, when you are giving it some heat from here, heat is nothing but energy. So you are giving them energies only. Now, when you are giving them energies, what is happening? Their energy, absorbing the energy, their energy increases because they are absorbing the energy. Got my point? Their energy increases, and as the energy increases, they start moving in random directions, right? Because this energy gets converted into the kinetic energy, isn't it? They gets converted into the kinetic energy. So the thing would happen is, if we just keep on hitting this object, they would start moving here and there. So if you just heat an object, they would start moving. The water molecules, the solvent molecule, they would start moving from here and there, here and there. So what would happen if they start moving with greater amount of speed? The intermolecular spaces are getting increased, right? They were here, now they're here. So the intermolecular spaces are getting increased like this, right? So as the intermolecular spaces are getting increased, they can dissolve more amount of solute now, right? Isn't it? So that is the thing happening here as well. So now they can dissolve more amount of solute. But let me tell you, it happens for some of the solvent, but this is not the case for each and every solvent. If you just keep on reading, in class 11, you'd be learning that there are some solvent like Ce2SO4, something like that. So for them, what would happen is, let me think about it. No, C2SO4. Okay, cerium sulfate. So for that, what happens is, for these type of things, if you just keep on hitting it, solubility decreases. So these type of, there are so many types of objects like that. You'd learn it in class 11. If you just want to learn it now, you just open your NCRT of class 11, you'd be able to see them. Okay, it's very interesting. I'm just telling you, this solubility part is very interesting. So in there, you'd be learning there are something more than what we are seeing right now. There are intermolecular interactions. There are like solute-solvent interactions, solvent-solvent interactions. There are so many things in there. Okay. Now, the second is over here is pressure. So how the pressure is changing the things. Okay, there is one more thing I've missed, like factors affecting solubility, forces of bonds, and like dissolves like. So, for now, we can just say, I can just say this thing. What do you mean by this word like dissolves like? So water cannot mix oil. Water would not be able to mix oil. Actually, the thing is, for now, to make you understand about it, what I can say is there are basically two types of things. Okay, two types of what should I say? Substances. Two types of substances. We call it organic substances, or we call it inorganic substances. So let's just not make it difficult. Organic substance can dissolve organic substances, and inorganic substances can dissolve inorganic substances. So what I mean to say is there are, it's not like everything can dissolve everything. Okay. So the thing is, water is an inorganic substance and oil is an organic substance. Why do we call it organic and why do we call it inorganic? That you would learn later in class 10. Okay, in carbon and its compound, you would learn what are the organic substances, what are the inorganic substances. Okay, organic substances are mainly that is found in our body from the organs. Inorganic substances are those compounds, those can be found from the minerals, can be synthesized on the labs. Organic substances are something like that can be synthesized from our body. Okay, so that is the thing. So they do not get mixed. Organic substances cannot mix inorganic substances. So from now we can say like that is there are the things we are going to learn in class 11. Fine. Now factors affecting solubility: pressure. So what would happen to pressure? So if you just increase pressure, then look at this picture over here. So first is when all these particles are over here and you are trying to mix it in solution. So gaseous substances are much influenced than solid. And so what is happening over here? So actually just look into this picture. This is water. And this is this, just consider this is a hydrogen gas. You are trying to mix this hydrogen gas in water. If you try to do that, it won't, let's say that only 5 grams of hydrogen is getting mixed. Let's say. Now, if you increase the pressure from outside, what would happen? You are trying to compress it. So now what would happen? More amount of hydrogen gas would get dissolved in here. So when you start giving pressure, the amount of the gaseous particle would get dissolved in. Right? Got my point? Now, explain the following, giving examples: saturated solution, pure substances, colloidal solutions, and suspension. So you just come along here. Saturated solution, I think you got it. They are the solution like where the solvent can dissolve no more. Definitely at a particular temperature and pressure. Okay, and pressure. You need to mention it. Pure substances that contains only single type of particle, isn't it? Like gold and silver. Pure substances. And colloid, so yeah, there are different types of mixtures as well. Colloid and suspension. So colloid is a solution in which the size of the solute particles are bigger than that of true solution. So what is salt and water? That is a true solution. For salt and water, the particle size is 10 to the power minus 9 for true solution particle size. For colloidal solution, the particle size is near about up to 10 to the power minus 6 meters, definitely. Okay, up to 10 to. So the particle size actually are bigger. So for that reason, you can see those particle size, and the particle size cannot be seen with our naked eye. So you cannot see that particles. Okay, it's like blood and ink. You cannot see the particles with the naked eyes. Okay, but they're bigger, like the milk. Milk is a colloidal solution. And suspension, you can use milk as well over here. Suspension, that is a heterogeneous mixture in which the solute particles are big enough than where in here suspension that is bigger than this 10 to the power minus 6 as well. Okay, so when the particle size are getting bigger, when the particle size is up to 10 to the power minus 9, we cannot see the particle after getting dissolved. That is called a true solution. Okay, that is a homogeneous solution. For colloidal solution, the particle size are getting bigger. Okay, that is a heterogeneous solution now because the particles are bigger. Okay, so they are not getting completely mixed. It's not like the system would be transparent like the true solution. It would be like translucent. I think you know the difference between transparent and translucent. It would be translucent type. Okay, like when you mix some milk in water, the thing that you get, that is a colloidal solution. And suspension is when you mix mud in water. If you just keep it for a moment, what would happen? That would get sedimented down because the particle size is so big that cannot get dissolved in there anymore. Fine, like the chalk water, the paints, the muddy water, you can see as well. Fine. So that's it for today. Okay. Thank you for learning with me, and keep learning with Ask IITians. If you have any doubt, you know what you have to do. You just have to write it on our forum. We'll definitely get back to you. Keep on practicing, keep on learning, and definitely I would come back in our next videos. Okay. Bye, everyone.